Hey guys, this video is for Algebra 2 NTI Days number 36 and 37. And you're doing the same thing on these two NTI days, and it's called rationalizing the denominator. So we're just kind of adding on to what you were doing before, which is solving these factors, so finding the solution from a factor. But in all of these, you'll notice that they all have this x squared, but they have a number in front of that x squared. So a lot of times when there's a number in front of that x squared, it is going to come down into something that looks like this, where you have a radical in the numerator and denominator. So the problem is when the radical is in the denominator. So when there is a radical in the denominator, you have to rationalize it, because you can't leave that radical in the denominator. It's just not in the most simplified form. So that's why you have to rationalize that denominator, because you'll never see, let's see, this, even though that's the answer, you'll never see the answer like that on the ACT, on any kind of like end of year test or anything like that. So I'm going to talk you through this first example that's given to you. So this one, my factor is 3x squared minus 5. So over here, I just solved that out. If you want to look at these on the Facebook page, everything is in color. So I try to switch colors to kind of like show you where the steps are. So it might help if you are able to look at it in color. So anyway, I've set my factor equal to 0. And I need to solve for x. So of course I need to add the 5 first. That gives 3x squared is equal to 5. And then I have to divide by 3. At that point, I have x squared is equal to 5/3, 5 over 3. And so to get the square off of my x, I have to go back and take the square root. So that gives me, of course, two answers, the positive and the negative. Make sure you are putting that plus or minus, or putting your positive and your negative out on the outside of these radicals. And then I have my square root, my radical of 5/3. So that is also equal to radical 5 over radical 3. So anytime you have a fraction like this, it's all in the radical, you can break it into two different radicals. So again, we have that radical in the denominator, which is what we don't want. So I come down here and we're going to rationalize. So all that means, and the ones that that I've given you guys for these 2 days, I've just given you the easiest type. So we're not going to go, get any more complicated, get any harder, because we're just going to look at these single radicals here. We have to multiply the top and the bottom by the radical that's on that denominator. So the radical on the denominator that I need to get rid of is radical 3. So I come over, I multiply the top and the bottom by radical 3. And the reason that I do radical 3 is because it's going to make that radical cancel out. When I multiply a radical times itself, the radical goes away. Because radical 3 times radical 3, they're both in the radical, so I get to multiply 3 times 3 is 9. But radical 9, or the square root of 9, is 3. So it's just going to cancel out. And then I do the same thing on the top, just multiply those numbers together. 5 times 3, 15. That number has to stay in the radical, because it's not going to cancel out, because it's not the same number. And then that is my solution. I just need to make sure I have the plus or minus to show that I have a positive radical 15 over 3 and a negative radical 15 over 3. When you have these, you're going to have irrational or non-real solutions. And this one would be an irrational solution. If it's non-real, you would have had a negative up here, which would mean that you would have to bring an I out onto the outside. So I'm just going to make up two random ones, or just kidding. No, I'm not. I'm going to show you number 1, like actually working it out, and number 6. So 2x squared plus 7. So number 1, 2x squared plus 7 is my factor, and I've set it equal to 0. So I have to move my 7 first by subtracting. I get 2x squared is equal to a negative 7. I have to get my 2 off, undo it by division. X squared is equal to a negative 7/2, 7 over 2. Get my exponent of 2 off by taking the square root. So at this point, I am taking my square root, so I know I'm going to have 2 solutions, plus or minus. I am negative on the inside, so I do need to bring an I onto the outside. And I'm going to go ahead and break it into the 2 radicals. So instead of keeping it in one big radical, I now have radical 7 over radical 2. And then I can't keep my radical 2 there in the denominator, so that is the number that I need to multiply by. Times by radical 2 times by radical 2. So I'm going to go ahead and bring over my plus or minus and my I. 7 times 2 is 14. And down here I have the same radical, so the radical cancels and I just get 2. And that's because 2 times 2 is 4, and I would still have that in the radical, and the square root of 4 would be 2. And that would be my final answer. And it does have an I on it, so that means that it is a non-real solution. And then real quick, I'm going to do number 6, because that one is just a little bit different. 5x squared minus 9. So I have it set equal to 0. I add my 9. So I get 5x squared is equal to 9. I divide by 5. X squared is equal to 9 over 5. I take the square root. And something a little bit different happens here. I do still keep my plus or minus. I'm positive, so I don't need to bring out an I or anything. But the square root of 9, is equal to 3. So I get to go ahead and put a 3 with no square root, because the square root of 9, my top number, is 3. But the 5, I don't know the square root of 5, so I have to still keep that in the radical. So this actually still needs to be rationalized. So I would multiply by the square root of 5, because that's my bottom number. That is the radical that I have to cancel out. Can't have the radical in the denominator. So I'm going to come down here to give you my answer. I still have my plus or minus. On the top, I have 3 times the radical 5. And that just stays just like that. 3 radical 5 over radical 5 times radical 5 is 5. It cancels out because it's the exact same, because the square, or 5 times 5 is 25. It would be in the square root. The square root of 25 is 5. So on day 37, you're pretty much doing the same thing, but I think on these last 4, you do have to factor tree your number down. So I just want to go over that with you one more time. So this one ended up with square root of 40. And so you can break 40 down however you want. You could use 5 and 8 or 4 and 10. I just went with 2 and 20, because 2 times 20 is 40. And then I have to keep breaking down 20, 2 times 10, 10, 2 times 5. So remember that you're looking for a pair of the same number, so 2, and that is why that gets to go on the outside of the 2. It was also a negative 40, so I went ahead and brought out the I, and then I have a 2 and a 5 left over, which allows me, I have to multiply those together. 2 times 5 is 10 inside my radical, and then that was still over that denominator of 5. So again, I'm pretty sure that happens on the last 4. I know it doesn't happen on anything above it, but you will need to factor tree, I'm pretty sure, on 8, 9, and 10.